In this video, we're going to run a workflow from the Chan Zuckerberg IDSeq Workflows repository. Specifically, we're going to be working with the WDL behind their consensus genome workload. So I've written the instructions out as part of the miniwdl course so that you don't have to navigate basically through this repository, but we'll be pulling from it. So to get set up, what you want to do is you want to follow the instructions on this page. So the first thing is you want to clone their entire repository so you have all the files. And the files we'll be working with are going to be under this directory, consensus genome, so the WDL and Docker files. The example sample data files that we're going to be working with to actually run our workflow for testing are under the directory tests. And we'll be working with two FASTA files there. To learn more about the IDSeq tool, see these links, and at the end of this video, we'll actually show running the WDL workflow with this tool. So to that end, we need an execution environment, and we'll be using something similar to what we used earlier in this series, but one of the things I found is that if I got an instance on Google Cloud with a little bit more resources, I was able to iterate my test faster, so I would recommend that. So what I did to prepare for this exercise is I created a VM of type notebook because, as you might remember, this has Python, pip, and Docker already on it. So I just created a new instance. The thing that's different from the previous parts of the series is I created a larger resource allocated instance. I have 16 CPUs, 60 gigs of RAM, and really importantly, I upped the default size of the disk. I found when I was testing that I ran out of space if I didn't do that. So I have 250 gigabytes of disk space for my working area. The default is 100. And this instance in US Central 1 costs about 50 cents an hour. So you do want to turn it off when you're done working with it so you don't get extra charges. As you may remember, when you work with instances, you can work with Jupyter Notebooks or Terminal. And one of the things I really like about this is I can see my directory structure here. So I'm working with miniwdl version 0.11.0 for this, and I've already set this up. So the first step in working with this particular WDL file is to build the Docker image that runs the tasks. So again, I have the instructions here in the course. So here's the Docker build command. Now I have gone and done this already, and it takes about 10 minutes on an instance of this size. And once you do that, then you will get a Docker image with this name, IDSeq consensus genome, with the default tag of latest if you don't change the tag. And you'll need that to actually run a test of the WDL file. So to verify that you have that, you can just go to the command line and say Docker images, and we're looking for, of course, that first one. And you can see it is 1.8 gigs. Now, in working with our miniwdl tool, we can take a look at the WDL file. The original WDL file in the repository is called run.wdl. I did make a couple of updates to it because of some syntax warnings that I found using some of the WDL tools, but I'm getting a little bit ahead of myself. So the first thing that I want to do is I want to just literally run this with no parameters. And do you remember why we do that? The reason is so that we can see which parameters will be required to run this WDL file. So you can see we've got a list of the required inputs, the optional inputs, the outputs, and then in red we have which inputs we're going to need to run this. Now, one of the things about running this particular WDL file is the inputs are assigned in a couple of different ways. As you might remember from previous WDL file runs, you can assign the inputs via addressing a downloadable site like S3 or FTP. You can associate them to local files. You can use an inputs parameter and then specify in another file, usually a JSON file, where the various files are coming from. And when we run this particular example, we have a combination of these techniques. So I'll show you if I drill in here that I have some FASTA files that we'll be working with. But we also have a couple of parameter files here. This local test, if we open this up, you can see that some of these parameters are being assigned and they're being pulled from S3, public bucket here, via this local test file. Now what this looks like when we run this, and I'll just clear the screen so that we have a little bit more space to see. And again, I've put these commands in here. Just copy this and then we'll kind of go through it while it's running. It takes about 4 minutes to run on an instance of this size. So I'm just going to start it. So the reason it came back so quickly is because I've run it multiple times and we have a caching feature turned on. And we didn't make any changes. So in a fresh run without caching, it would take about 4 minutes to run. Came back a little quicker than I thought, so let me just go through this command. So we're running the update run. The Docker image is the one that we created. Here are the FASTQ files. Those are on our machine. And then we have the sample. And then we have this local test YAML, which is pulling some of the other required files for this. Again, we can run this with the verbose flag, which we saw in previous movies, which can give us more log output. We could also use debug, and then as I mentioned, we could use the inputs as well. So in working with this, one of the things that is important and can really help out your testing, as I just sort of unwittingly demonstrated, is if you turn on the caching feature, you can use one of two types of caches that are available in miniwdl. So this is set up through this command, miniwdl configure, and I had already turned this on. I sort of had meant to turn it off and then turn it back on, but we'll just do it this way. So the call cache and the download cache are both set up to true. Now I'd recommend that you take a look in the documentation, which is right over here, and this talks about what is being cached when you enable one or both of these caches. So if we click into this link right here, you can see if we scroll down, the call cache here, it talks about what is being cached, and here's all the details. And then the download cache, again, if I scroll down. So this can really speed up your testing, but again, you obviously need to understand because you may or may not want certain parts of your run to be cached depending on what you're testing. But it's a great capability that's built into miniwdl, so I wanted to show you it in this video. So in addition to being able to run this, you could also use syntax checking on the WDL file. And that's something that I'm actually working with because I'm working with the team on refactoring this WDL file. So you might remember from previous movies that there's a check command. So we're in progress on this, so you'll see that we've got some of the calls have no errors, that's what's listed here, or warnings, and some of the other calls have some warnings. So again, when you're working with this WDL file, or really any WDL file, you are probably going to want to use this check and then figure out with your team which of these warnings you want to address. Now, in addition to running this on GCP, I thought it would be really interesting to, as a comparator, run it on AWS. Now, to make it as fair as I possibly could, and it's really tricky to get exact same instances, I used the search capability to search for instances that were about the same size. So 16 CPUs and 60 gigs of RAM. And then you'll remember I upped the default size of the disk from 100 to 250 gigabytes. Now also I wanted to use a Jupyter Notebook enabled instance because again, those generally have Python, they have pip, they have Docker, so you get up and running faster than a raw VM, which in the case of Amazon, of course, would be EC2. So I used Amazon Sagemaker and created a notebook instance, which is the Amazon equivalent to a notebook instance on GCP. Interestingly, it appears to be about double the price, so about $1 an hour. So maybe I'm just not finding the most optimal instance, but That's just something to be aware of. You're going to want to see how much the instance costs, and again, make sure to turn it off when you're not using it. Once you have your instance set up and you install miniwdl, you basically kind of have the same interface. It's almost kind of tricky. You can see up at the top, US West, Sagemaker, and over here, US Central, Notebooks, Google User. I mean, that's about the only way you can tell you're in a different environment. So, I have miniwdl here, and then let me just get in the right directory, and I think I have everything here, consensus genome. So I should be able to just run, and I did turn on the caching here as well, so we'll see if we get the same super fast run. This one's actually running, so this one might take 4 minutes. Maybe I didn't turn the caching on here, to be honest with you. We can check, of course, with miniwdl. Now, while this is running, I'm going to take you over to the tool that the CZI team built that is a graphical user interface that uses this WDL file. And in fact, I couldn't even finish my sentence, and then it finished, so it finished pretty quickly. I found in my testing that without a cache, with these sample data files, this WDL file ran in about 4 minutes. With a cache, it came back in between 30 seconds to 1 minute, turning the caching on, which is a testing window that, for bioinformatics, I was pretty happy with, to be honest with you. So to take a look at what this looks like in the IDSeq tool, and again, I'm just really giving you a preview to this. There's much more to this tool. You go to upload data, you select or create a project type, and then this is the SARS-CoV consensus genome. Then you select your wet lab protocol, and then you select your files. So we would upload these two FASTQ files, and then we would select our project, and then we would click continue. Now here we would select our host organism, sample type, whether it was water controlled, nucleotide type, collection date, and then basically we would review. Yep, and then I would upload, and this will take about 4 minutes again. Now when this is done, because this is a tool rather than a WDL file, it includes a number of integrations around understanding the results, and so I encourage you to really take a look at this tool. Now you can see this is running right now. Of course, cooking show style, I have one that's already done, so let me go and find that one. And once you're done with it, you can drill into it and get useful visualizations about the data that was found in the analysis. And also there's some, even more data by clicking here. You can also go out now. This is kind of a new release the team was justifiably excited about. It integrates with this Nextclade visualizer. So, and you can use a default tree, or you can add your own tree. And again, you can see the result here. So, lots of different things that you can do with the WDL file, from running it manually on, your laptop, to my preferred way, which is running on cloud instances, to alternatively using the IDSeq tool. This shows you a number of ways of working with the consensus genome WDL workflow.